Okay, the answer key to the AP Physics C quiz on magnetism, magnetic forces. A says, in what direction must the magnetic field point for the current trajectory to happen? So my index finger is going to point towards the top of the page or screen because, well, that's the direction that the charge is going. I'm going to use my right hand because the charge is positive. Now I'm going to hold my hand while my index finger is still pointing up. I'm going to hold my hand so my thumb is pointing to the left of my screen. And I see that if I were to extend my middle finger, keeping it at a right angle to my index finger, I would be pointing towards the screen. So it's going to be into the page. So towards, let's see, into the page. There we go. Well, that's fun. Let's try that again. Now, come on, into the page. And, alright, success. So that was just a coding issue with creating this question. Come back here. The ions travel at constant speed in a circular path. Explain why that happens. Well, the reason why that happens is because let's just think about the instant it enters the field. This is the velocity vector, and this is the acceleration vector, and they're 90 degrees. And just like in orbits, they always stay 90 degrees apart. So you can't actually change the speed, you can only change the direction. Moving on to C, calculate the speed of the ions. So we are looking at the summation of forces equals ma. It is a circle, so the acceleration will be v squared over r. The only force present is the magnetic force. Magnetic force is qvb sine theta, and that is because it is the magnetic force acting on a particle. The sine of theta is 1 because theta is 90 degrees. We can cancel out one of the velocities. And our final step is, since we're solving for v, let's move m and r over to the other side. So qbr over m equals v. Q is 2 times the fundamental value of a elementary charge, 1.6 e negative 19, 2e. The B strength, 0.090. R is half of 1.75. And the reason why it's half is I only want the radius of this circle. And X is given as the full diameter. And mass is given as 1.45 e negative 25. So pull out the calculator. 2 by 1.6 e negative 19 by 0.09 by 1.75 over 2. And divide that by 1.45 e negative 25. The result is a very big number. I got 173,793 meters per second, or we could call it 174,000 meters per second. Kind of round, call it a day. Let's check it out. 174. And of course, victory. As I move on to part C, I'm going to stick with the 173,793 because I do need that answer to answer part C. What I'm going to do is I'm going to delete this information on question C, so that way you can see the work being done on question D. All right. So D says calculate the accelerating voltage. Well, what did this particle get? It got kinetic energy. And where did that kinetic energy come from? And it came from electric potential energy. Electric potential energy is Q delta V, and kinetic energy is 1/2 mv squared. So that accelerating voltage is going to be mv squared over 2q. So the mass, 1.45 e negative 25. V was just solved, 173,793. We'll square it. 2 times the charge, 2 times 1.6 e negative 19. Punch all this happy fun stuff into a calculator and hope that you keyed it right so that way you don't have two mistakes on one video. And I got 6,843 volts. Assuming I punched everything right in my calculator and whatnot. So 6843. Check out 6843, hit enter, and no. Yeah, so you remember when I was saying on the first week there's going to be kinks? This is a kink. 6843 was correct. It was just keyed incorrectly on the code for the question. Cool. Enjoy.